Hello, we're going to be doing an example, problem 3.6 from the textbook. And so this is the setup. We have a span here that's 16 feet wide with a fixed point on the left-hand side and a rolling point at node 3. Each length is 8 feet. And we're going to put this into ANSYS, analyze it. So we're going to go ahead and open up ANSYS. Now, when you do that, make sure if you're at home or not in a lab that you first VPN into the CS-ENGR network. Then you can go APDL for the search, or go look through the menus for ANSYS and select the Mechanical APDL 15.0. Go ahead and start that. It'll come up. I like to maximize it typically just to fill the screen here. All right, now I'm going to go to File, make sure we label it correctly, give the job name, and we'll call this Truss number 2, since we already did Truss 1 in class. And we got change title, we'll change that one as well, Truss 2. Okay, so again, we're going to start on the left and work our way down. So start here at Preferences. Click there. I'm going to go to Structural right away, and to kind of just limit ourselves to the things that we can use for our structural analysis. Click on OK. We're going to go to our Preprocessor, and working ourselves way down. We got Element Type, Add, Edit, Delete, and we'll go ahead and Add. And again, because we're looking at our trusses here, we're going to be using links and then the link 180. Right, so this will allow only 2 forces to be applied to each of these members. Go ahead and click on OK, and then close. All right, and then we're going to go to Real Constants, Add, Edit, Delete, and we're going to add the real constant. And sometimes there'll be multiple ones here, but in this case we only have one. So go ahead and select OK for the one we have. And when we have one real constant, leave that value as 1. We go to the area. All right, we'll have to look at our sheet and see if the sheet indicates that we have a cross-section area of 2 inches squared. Again, remember the units. Right? It doesn't say it anywhere here, but you have to remember in your mind that you have now chosen inches in this particular case. All right, so watch those units. So click on OK there, and we'll close that window. And we'll keep working our way down here. So go to Material Properties, and under Material Models, we'll select Structural, Linear, Elastic, and then Isotropic. Modulus elasticity, again, if we go back to our handout there, for structural steel, our E is 30 times 10 to the 6, so we can do E6. And this is pound per inches squared. So we're already in inches, so that's good. We're staying there. We're doing pounds now for our force. Right, so we're going to remember that. We can plug in here for the Poisson's ratio. We'll put in there 0.3. And go ahead and click on OK. And we can go ahead and just close this window for the material behavior. I'm going to save DB, save the database. Again, you want to know where it's saved to. You can go up here to File, come down to Save As, and you can check out where it's being saved to on yours. Mine looks like under Users Mic directory here. All right, so let's set up our working plane so we can pick our nodes coming up next. So we go to Work Plane, and we'll go to Work Plane Settings, WP Settings. We're going to do Cartesian, which is good. We want to show the grid and the triad. So the grid is going to be the grid that we're creating. The triad is going to be what you see here in the center of the screen. We want to make sure we can see this too. It's going to be helpful as we pick out stuff. I'm going to change our snap increment to 12. So we'll look at, this is in 12 inches. So we can look at every snap or location on here is going to be every foot. We'll also do our spacing here at 12. All right, so the spacing is 12 as well. Minimum will be 0. The maximum, let's go back to our drawing. All right, so the drawing here says we've got 8 feet here, and we need to be able to go to another 8 feet. Going up vertical right? Not necessarily 8 feet there, so we need to have to watch that, but at least we need the 16 feet here. So if we bring up the calculator, we got 16 feet times 12, give me our 192. All right, so let's go back in ANSYS and put in our 192. Oops. All right. So we'll do maximum is 192 inches. That'll be our 16 feet. And we'll call that done. So I click OK. All right. Now it's created the grid, we just can't see it. So we'll go up to Work Plane and Display Working Plane. And we'll minimize here because we're really zoomed in. Minimize till we can start to see it. And pan it over. All right, we'll pan it down some more. All right, that looks good. All right, so now we're going to put our nodes on here. So let's go to our modeling. So in a preprocessor modeling, we're going to create a node. And so create node on working plane. So that's what we're showing here. So now here's the picker where we can select our nodes. All right, so if we follow the nodes in our drawing here, we have 1 on the left side, 2 in the middle, 3, 4, and 5. We'll keep those numbering, so let's select those accordingly. So we'll go 1 is here, then 1, 2, 3, 4, 5, 6, 7, 8. There's going to be node 2. All right, we can see the number here as it's counting up. So 8, 1, 2, 3, oh, no, it's all the way over here, right? Because that's how we set it up, the 8 feet. Now as we go up, oh, it's not exactly on the foot, because well, it's 8 feet the length of the equilateral, so this is 8 feet here. But this right here, this dimension, we don't know for sure what that is. Well, I have an idea, a little bit less than 8 feet, but it's not right on the foot. So coming back here, we'll go ahead and click OK for those nodes, so apply those ones. All right, and we need to come back, we need to figure out what the other nodes are. All right, so to figure out what this length is here, all right, this distance here, all right, we have to find this from the stuff that we know. So we do know this. We know this distance here, this is going to be 4 feet. All right, and we know this length here is 8 feet. All right, so we can know we know about triangles and say a squared plus b squared equals c squared. And if we say this is our b, all right, and this is our c, then we can figure out what our b is. All right, so let's go do that. So I have Wolfram Alpha up here, and we can go ahead and type in sqrt to get our square root. And we'll do our c squared, which is 8 squared, and we'll subtract off our 4 squared, and we'll get a result. So down here we got our decimal approximation. I'm going to go with 6.93. All right, so 6.93 is this value here. So we got 6.93. Terrible writing with my mouse. All right, but we can use that to figure out the location of this node number 4. We got 1, 2, 3, and then we're going to put 4 up top here. So now instead of on working plane, we're going to use inactive CS, right, inactive coordinate system. So click on that one, and I'll bring up this box. So this is going to be node number 4. So go ahead and put 4 in there. We go to the next one, we're going to locate this based on our coordinate system. So if we want to go over, so X is in this direction, you can kind of see a WX here. So we're going to go X is going to be over 4 feet, so that's our 48 inches. Our Y, right, if Y is going vertical here, it's going to be the same as what we just calculated. So if we go back here to our 6.93, that's in feet. Right, so this is 4 feet. This is 8 feet. So we need to change that feet into inches. So going back to our calculator, down here, we got 6.93 times 12. All right, so we got 83.16. So we'll type in our 83.16. And then we're not going in the z direction also, we'll put a 0 there. All right, so we go ahead and hit apply. If you hit OK, you can. What it's going to do is going to close the box, and you have to open it again to do node number 5. So we'll go ahead here and hit apply, and it saves everything for you. But we'll go here and put in 5. Now, the y distance is going to stay the same. The y doesn't change for node 5. What does change is instead of 4 feet, we're now going to be, if you go back here, we got 8 feet plus then another 4 feet. So we got 12 feet we got to put in here. So if we go back here, so 12 times 12 is 144 inches. All right, so go ahead and hit OK on that. And let's go back to our ANSYS window. And there we go. We got 4 at 4 feet, almost 7 feet. So I guess in some ways we could just pick 7, but to be as accurate as possible. And to show you this, how you can use this in other cases in future problems, this works out pretty well. All right, so we have our nodes there. We got node 1, 2, 3, 4, and 5. All right, so we don't need the working plane anymore. It was there really just to help us put in our nodes. It really was just 1 through 3. So we go ahead and hide that now. So we'll click on Display Working Plane. And this issue came up a lot in class. What I'm going to do is show you here, if you would replot this. So you go into Plot and Replot. Say maybe started things getting messy or deleting stuff and you weren't sure what was there. Go ahead and click Replot. All right. Now in this case, the node shows up, but sometimes they're going to disappear. All right. So you click on Plot and then click on Nodes. All right. So here the nodes have been replotted, but what's missing now? We don't have the numbers. So to get the numbers back, we want to go under our plot controls and numbering. So we got plot controls, numbering, and come in here and we said no numbers. Well, yes, we want to see no numbers. So we'll click on there. And we haven't drawn any elements yet, but we can also turn this on and say, hey, I want to also see the element numbers. So now we'll see node numbers and element numbers drawn when we replot. Right, so there are node numbers. Right. Again, if you want to check, so maybe you maybe click twice for a node. You're not sure if you have too many nodes here, or you delete them. You want to see. Always go here to list, and you can do this for lots of things. Obviously, you can see on this list here, but nodes, you go into nodes, and you can do with angles if we have them, but don't have to worry about that. So we'll just do coordinates only, and click on OK. And then it'll show you the node numbers, and it'll show you the X, Y, and Z position of each one. Okay, so those all look good. Okay, go ahead and save DB. All right, and we're going to go to applying, putting in our elements. All right, so if we come down here, instead of nodes, we'll go to create elements. All right, and we'll put in our auto-numbered elements, and we'll do them through the nodes that we just created. So a very nice way to do this one. All right, so here's our picking window. And while our picture here doesn't have any elements numbered, let's kind of follow. If you want to follow along, great. I'll just kind of make it up here as I go. So I'm going to go from 1 to 2 first, and middle click. All right, and I can go 2 to 3, and I'm going to middle click. And let's go across this way. So we'll go 1 to 4, middle click, 4 to 2, middle click, 2 to 5, middle click, 5 to 3, middle click, and 4 to 5, middle click. So the direction in which you click, so node 4 to node 5, the orientation doesn't really matter because, again, that's setting up the equations. You're not setting them up. ANSYS is doing all that, and the results then would be the same either way you clicked them. So if I clicked 4 first, and then 5, and then 5, and then 4, it wouldn't matter. All right, so let's say, maybe something goofed up and I want to delete this. Let me show you what happens there and just go through the deleting process. So here's modeling and create, but instead of create, I'm going to delete. All right, so let me come back here and I'm going to delete. What am I going to delete? I'm going to delete an element. So click on element. And I'm going to delete this element number 7. So I'll go ahead and click on that. And if you need to pick all for some reason, it's something that really gets bad, you can, here's a pick all option here. So go ahead and click OK. Now, wait, I thought I deleted it. Well, let's check here. So if we come up to plot and replot, all right, notice how everything disappears. Now it looks like they all got deleted. Well, what happens here is that when the replot action happens, it's not replotting the elements. So you have to come up here to plot, and then down here to elements. All right, and there it shows, oh wait, element 7 is definitely gone, and all the other ones are still there. All right, so that looks good. Also, again, another check, if you go to list, elements, and attributes, and there you can see each element number 1, 2, 3, through 6. And in the material, so we had one material type, so that was number 1. The real constant 1, and some other information, what nodes the elements are made up of. All right, so we want to now put that element back in there. So let's go back up to our create, and we're going to come down to elements, but then instead of auto numbered, let's skip down here to user numbered. All right, so normally it probably looks something more like this. So let's skip down, instead of auto numbered, let's go down to user numbered, and we'll do through nodes. And you can see here's it allows us to assign the number. So we want to again do number 7. Otherwise, we'd be at some higher number. All right. So we can now put in the number that we actually want to use. So we'll go with 7 and click on OK. All right, we get that picking window. So we'll pick nodes 4 and node 5. Middle click to confirm. And now it's ready to do another one. Well, we only want to do 1. So we'll just cancel that out. All right. So go back to the list here. Make sure they all look good. Look at our elements, so 1, 2, 3, 4, 5, all the way up to 7. That looks good. So we have all those drawn. So let's go close down modeling as we work our way down here. All right, the next thing we got to do is loads. So again, I said you could do it through this menu here, right? Or you can do it through solution. Either one's fine. I'm going to go through it ahead and do it through solution. So we're going to define loads. So we need to apply the boundary conditions as well as apply the loads to the system. And they actually are both done through here. So we're going to apply, and we're doing with structural. And let's start out with the boundary conditions first. So we're going to do displacement, and we do it on nodes. And we have in this point right here, let's go back to our picture. We have this pin joint, right? And over here we have a roller joint. All right, so this one's fixed in all directions, and this one's only fixed, or what basically allows it to roll in the X direction. All right, so come back here, and we'll select at this point, and we'll say OK, and we'll do all degrees of freedom are fixed, and therefore the constant value, displacement value, is going to be 0. So again, make sure you just select this. You get a blue there. Click on OK, and you get the 2 blue arrows indicating what the boundary conditions are there. We'll do it again, and this time we'll pick the other side, and click on OK. And we'll say only in the Y direction, so make sure only the Y is selected as blue, is going to be 0. All right, well, it can still move, and we could put it in the Z direction too, but basically it can only move in the X direction. We'll click on OK. All right, so we have our boundary conditions applied. Now let's do our force. So going back to our picture here, we got our force is going to be 1,000 pounds down at node 2. So if we go apply kind of force, so we get structural force, and apply it on node. So we node number 2. Go ahead and click on that and click OK. And this is in the Y direction. So if we look at our triad over here, it's going to be in the Y direction. But this triad indicates the positive direction. Now our force is going in the negative direction. It's going downward. So we're going to do a negative 1,000 pounds. And a pounds is our unit of force, so we're okay there, right, that we've used before. And then we'll go ahead and click on OK. All right, so maybe pan up here a little bit so we can see that force being applied. All right, so we applied our forces, applied our boundary conditions. So it looks like we're done. Let's go ahead and solve this. So we'll go back to solution and solve. We'll do the current LS. Click on OK. Solution is done. Go ahead and close that window. And it's always neat to see, really quick feedback. Let's go to our general post-proc and plot results. Look at the deformed shape compared to the undeformed. And go ahead and click on OK. See, it's down there. Everything's moving well. It actually looks like it displaces slightly to the right, which makes sense because we're fixed over here on the left-hand side, and the right-hand side has a roller joint, so it can move in the X direction. So we can see on the deformed shape perspective what has happened. All right, but you guys want some more results than just these, so let's go look at how we can get some other values out of here. So we want the displacements, so we'll go under list results, and we'll go list the nodal solution, and then we'll go degrees of freedom solution and displacement vector sum. Click on OK. And there we get the displacement of each node in the X, Y, and Z directions. One thing I forgot to point out in class, and what hopefully you notice here, is there's no units. All right, no units are given here. So you need to indicate whenever you present these results, if you copy and paste these into your document, that what units are they? Right, in this case, they're inches because we define length as being inches in the process of entering our data or entering our values up front. All right, so those are our displacements. Now, if we want to get some more information about the elements, we need to go down to element table. All right, so we'll close list results and we'll come down here to element table and we'll expand that. First, we need to define what's going to be in the table, so we'll click on define table and we'll add. All right, so we can just put 0 here and just our label here. So initially, we're going to look at the axial force, that's AX force. And slide down until we get to the by sequence number. And this is just the number that ANSYS has to remember that this is how you calculate axial stress. So it's S misc and then a value of 1 in this table right here, or this box. And go ahead and click OK. And we'll also want to do this for the stress, so we'll go and add another one. So we'll leave 0 there and look at the axial stress. And come down to the sequence number, and this time will be LS and 1 box, and click on OK. This time we get the force and stress defined. Let's go ahead and close there. So now we've defined the table, so now we can go ahead and plot or list the table. So if we want to plot the table first and maybe want to look at the stresses that are in here, go ahead and OK. Now it's got the coloring here, so we got some compressive stresses in these members. We got tensile stress here, and then the yellow is still some tensile stress, but much less than what these two are experiencing. We want to see the actual values for these. We can go into the list element table, and we'll select our force and our stress. Just clicking on them, make sure they're blue highlighted, and clicking on OK. And there we have our force and our stress, but they're not in. They don't have the units shown. But we know that we define force as being pounds by the data we put in initially with the modulus elasticity. And then stress we know is going to be PSI because we use pounds per square inch when we define stress. All right, so again, those things you'll need to highlight in the homework when you put this data in there. And we're going to close that. And if we want the reaction solution, look at the reaction forces. We'll go back up to list results and reaction solu. Click on that and leave it at all items. It's fine. And click on OK. And we can see that we have for node 1, right, has a reaction force, right, very, very weak in the X direction, but a lot in the Y direction. And then node 3 has nothing, looks like, in the X direction, which makes sense because it has a rolling joint, and then 500 in the Y direction. Right, so those look very good in our data, and I hope this provides some value information for you. Thanks.